Hey everybody. So today I have a board that I'm working on. I've been wanting to show you this kind of video for a while, and I finally came upon a board that has this issue. This issue is where you plug in your adapter. Let me just plug in my adapter here. Got the MagSafe board. Plug in the adapter and you notice you don't get any light at all on the adapter. So it looks like you're getting no power to the board. This issue, this particular board is a 2009 model. It's an 820-2530 board. So these boards may not be used as much anymore. Every now and then you might come across a customer that wants one repaired. But this issue can be the same across many other boards that are more common. So the issue with this board is it's called the one-wire circuit. When you're getting no power on the adapter, that's one of the first things you check for. You check for your 3.42 volts and you check the one-wire circuit to see if you have any damaged components. So what we're going to do, I'm going to show you on the schematics here. Right here we have the one-wire, it's called the overvoltage protection circuit. And you see here, this is the MagSafe DC power jack right here. This is what we plugged our adapter into. And this is the adapter sense. Now this is the line, the one circuit line that goes down over here to this U6900 chip. And this is a bidirectional line right here, system one wire, that comes in and out of the chip. The reason you know it goes in and out is because it's a bidirectional line. Now you see right here next to where it says it says 40. You go up to page 40 and you can see what that's talking to is the SMC. See right here, the SMC. So, and this line, let me see if I can locate it here. It's right here, system one wire. So this is going, and it's right here. You see again, it's bidirectional, and this is going talking to your SMC and talking back to that U6900. So go back down to page 58. Alright, so we have that talking, and so if that's not talking correctly, you're not going to get the adapter sense to realize that it's plugged in, and it will not allow the adapter to give power to the machine. Also, you have the U6901, and you see right here 3.42 volts G3 hot one wire. This is coming directly from your 3.42 volts power supply, and so if you're not getting 3.42 volts on your board, if you have something wrong with that supply, you also will not get your one-wire circuit to power on. So these are the two things you check right away when you don't get an adapter light turning on, is your 3.42 volts as well as your one-wire circuit, these U6901 and U6900. You check these components to see if you have any damage with those or the trace. I know on this particular board, a lot of times you get trace damage, or there's a via in the board that gets liquid damaged and it corrodes and no longer allows the signal to pass through. So we're going to look at this first of all on the board view. Let me pull up that. Alright, so right here we're looking for the U6901 on this board. Kind of get a better view here for you. Oops. Cancel that. Alright, so we're going to search for U6900 and U6901. Okay. And so right here we have U6900. On the other side of the board we have U6901. And this is the LVDS port right here. So that's our display port. And so right here is the U6901. And the other side of the board, on the back side, your display ports like right here on the other side of the board, you have the U6900. So we're going to look at those under the microscope and see if we can see any damage to those areas. So right here on this side of the board is U6901, and right away you can see the issue with this. Let me zoom in on it so you can see it. This is the via I was talking about, the trace is actually damaged going through the board. So that here you have this pin right here, and I'll show you on the board view. So here's the display port we're looking at. Let me zoom back out. Get you in focus. Alright, so here you see the display port, and this is the display port, and then U6901. Here you have that right here, and you see how it has the 5 legs. It has 3 on this side and 2 on this side. So the one we're looking at is this one right here, PP3V42 G3 hot, or G3H. So this is the pad. Let me zoom back in over here so you can see. So you see this pad right here is your 3.42 volts, and it's supposed to go to this via that goes through the board, but you can see it's corroded. You only have a little bit of copper showing left there. So this is the problem. It's not getting the 3.42 volts to the chip. So what we're going to have to do, let's flip it over and look at the other side of the board. See, here's your V over here, and it looks a little corroded as well, so it's not trustworthy to just run a wire over here and solder on this side. I'm going to find where else the 3.42 volts is coming from and run a wire that way. So let's look on this on the board view. And so here you just click on this and we'll see where else we have power. So you see right here this capacitor. So we're looking at that capacitor there. This capacitor right here on this side. So we're going to solder a wire there and run it over and to the other side of the board onto our pad here. So that since we're not getting power through that via, we're just going to run a wire and make it get power. So let me get you back in view. Let me just show you full screen here, the microscope. Alright, so first off, when I do something like this, I find it easier to start on the, and it just depends. It depends on how you want to do it, but I'm going to start soldering right here on this capacitor first. Soldering a wire, and I think what I might do, because we have to go over the board in this area, so if I go up at an angle and over the board, I don't like doing that because it twists the wire. I like to go directly over the board if I have to cross over. So I think what I'm going to do is run a wire through these capacitors, like from here through the capacitors and then up and over the board onto the other side. I think that'd be more steady and solid. So let's do that. First off, I'm going to add a little flux. Oops. Turn my light off. There we go. Turn my soldering station on. I'm going to add some solder to my capacitor there on that right side. So I have something to solder the wire to, make it nice and firm. Waiting for it to heat up. Alright, so we have some fresh solder in our joint there. Now just get a little bit of wire, and you can buy this wire on Amazon or anything. What I don't have the roll with me. I think one of the other workers has it, but what I'm going to do is just solder the tip of it like this. I'll make sure that I have it nice and solid. Got a little more flux to the area to make sure. I like to hold it with tweezers in place because you can get a lot closer that way. Okay, So I think we're good there. Let's just make sure that it's not going to bridge anything. That's what happens when you try to be perfect with it. You just end up messing it up. Okay, so I have that good. And like I said, I'm going to run it down. I'm not going to pull too hard on this because I don't want to pull it off. But see, this is insulated wire, so it can touch these other pads here and not be shorted out. I'm going to go through it like that. And then flip over the board. I'm going to come up and over this way and solder it like that onto the pad there. But first, I'm going to add a little more solder to the pin. Okay. And now I'm going to pull the wire over the top. And you'll see that the insulation of this wire will burn off. See how it burned off like that? And now you have a nice solid connection there. So to get it hot and to break this wire, I just kind of move it back and forth, and the wire will break off. So now we have a nice solid connection, this nice wire that's not going to move around. It's running directly over here like that. And to keep this wire from being messed with over here, first I'm going to clean off this board, and then I'll add some conformal coating over this and dry that up so that's nice and solid. But first, before I do that, we're going to test the board and see if we have a light on the connector. I mean the adapter. So plug in our MagSafe like that. Plug in the power adapter, and looky there, we have a light, a green light. So let's see if we get a fan spin. Right, plug in the fan, plug in our adapter, and now with this is a Core 2 Duo. These don't turn on automatically, so you have to the way to bridge it, or start the machine up without a power plug, a keyboard with a power button, is these two pads right here. We're going to bridge that just like that, and you'll see the fan will spin up as soon as I do that. See? So we now have power to the board. So this board is good to go now. So I'll go ahead and clean off the board and be back in just a moment, and I'll show you how we add the conformal coating and cover up the wire to make it no longer loose like it is and make it solid. So I'll be right back. Okay, so we cleaned off the board, and I'll show you under the microscope what we have now, how it's cleaned off, and we just have the wire there. Get back in view for you, or focus for you. So here we have our wire that's going over to this side of the board, and everything's good. So now we're just going to add some conformal coating. And I have this in a tube, like this. It's like Seal Glow is what it's called. and it kind of dried out on the tip, so now I just have where I just pull out with this tool, and I just put it on the board and spread it around. Then you use a heat gun to slightly heat it up and dry it. So I'll go ahead and do that now. Get back to the board or the microscope view. I'm just going to pull some out with this tool. I really need to buy some more of this because it's kind of drying out. You can see I'm putting it on pretty liberally. And the reason for doing this is if the customer gets it and snags the wire, it's going to end up messing it up again, and we don't want that to happen. We want that wire to be nice and solid and not be moved around. So now we're going to heat this area up. I'm not applying the heat absolutely directly to it. I'm holding it a little way away from it, because you want it to not burn, you want it to dry, slowly. See, it's starting to harden. It's getting less shiny. I want that to cure as much as possible. Let that cool off. You can see it's nice and hard. So that's going to cover that wire up, protect that wire, and keep that wire from coming off when the board is being installed. And this side over here, there's not much wire exposed at all. It's just a little bit. This isn't going to cause any problems, I don't think. So we don't have to worry about covering that up. Board is good there. So that's how you fix that problem. Like I mentioned, it's the one wire circuit. It's one of the first things you want to check for when you're not getting a light on your adapter. It's your one wire circuit and also your 3.42 volt signal, your supply. If you're not getting either of those, if either of those is messed up, your adapter is not going to light up, you're not going to get any power to your board. So I hope this helped you out. I know this is an older board, 2009 board, but the same principle applies to boards up until recently. I know the MacBook Air boards have the I/O board, like the MagSafe I/O board. That one wire circuit is on the I/O board, not the logic board itself. So you can still repair those. It's the same principle with those as well. Well, I hope this helped you out. I hope you learned something, and we've restored another board, get another board working so that we can get the customer happy. If you enjoyed it, give us a thumbs up, like, and also follow us or subscribe so that we can keep you posted with more videos coming in the future. Alright, hope you have a great day.